Hello, ladies and gentlemen. Welcome back to Math 30-3, Chapter 2, Tolerances, Part 2. Now, we just showed you the 4 different ways to write out tolerances. I forgot to stress something. This nominal value, plus or minus half the tolerance, looks an awful lot like a measurement, but it's not. Okay? This is not a measurement. Remember in the last unit, accuracy and precision, we talked about how precise the measurement is, how accurate it is. So if you're measuring something, it could be 12 millimeters long, plus or minus 2 millimeters, depending on how good your ruler is. But this is nominal value, what you're aiming for, plus or minus the tolerance. So be careful. Okay? Anyway, just stress, tolerance is the measurement variation allowed so that an item is acceptable for its intended purpose. A nominal value is the target value for a measurement. So once again, whenever you're making or creating something, there's some tolerance allowed. If you're baking a cake, you have a little bit more tolerance, actually baking a cake, you're cooking a piece of meat. There's quite a bit of tolerance there between rare to medium to well done. Nominal value you're aiming for medium. Tolerance is how close you want to get. That's a crappy example. I'm just talking about food, making myself hungry. Anyway, let's do some examples. That might be easier. So, Mackenzie's making caramel candies. The recipe says to use a candy thermometer to monitor the temperature of the sugar mixture. If it's not heated enough, the candies will not hold their shape, and if it's heated too much, the candies will be too firm. The sugar mixture must be heated to between 245 degrees Fahrenheit and 250 degrees Fahrenheit. So, the question is, what is the temperature tolerance of the sugar mixture? Well, the tolerance is the maximum value, 250 degrees Fahrenheit, minus the minimum acceptable value, 245 degrees Fahrenheit, which is 5 degrees Fahrenheit. And I still can't believe we're talking about Fahrenheit in this day and age, but still. So that's the tolerance. It has to be within that 5-degree band. Too cold, it doesn't work. Too hot, it doesn't work. Now, write the acceptable temperature range in each of the 4 ways shown above. Now, you also need to calculate the nominal value. Now, the nominal value at the maximum minimum values divided by 2. So nominal is max plus min divided by 2. So that's 250 degrees Fahrenheit plus 245 degrees Fahrenheit divided by 2. That is 495 degrees Fahrenheit divided by 2, which is 247.5 degrees Fahrenheit. All right. Now, as you said, write the acceptable temperature range in each of the 4 ways shown above, or previous page actually. So go back here. Maximum, minimum value, maximum value. So the minimum value, first way, minimum value is 245 degrees Fahrenheit, 250 degrees Fahrenheit. The second way, that's one way. The second way is the nominal value, 247.5 degrees Fahrenheit, plus or minus half the tolerance. Well, the tolerance is 5. Half of 5 is 2.5 degrees Fahrenheit. Okay, that's a different way to write it out. All right. 247.5 halfway, plus or minus half the tolerance. Now the third way is minimum value plus the tolerance. So if we go minimum, third way, that's 245 degrees Fahrenheit minus 0 plus 5 degrees Fahrenheit. And the fourth way is the maximum value confusing. All these ways, 4 different ways to write it the same thing. Now, here's the problem. This sort of thing depends a lot on who's doing it and what they're aiming for. If you're worried about going too small or too big, or you're aiming for the middle. Anyway, so remember, this is min, this is max, this is nominal, plus minus 1/2 tolerance. This is the minimum value, and this is the maximum. So, some people, if they're worried about the maximum value, they'll write it the fourth way. If they're worried about the minimum value, they'll write it the third way. Some people do the nominal, aim for the middle, and go plus or minus half the tolerance. And some people write it the blue way, just show the minimum maximum. No way is perfect. Like I said, go back, I'll just shut up for a second and let you copy this out. Like I said, go back to the examples I did, particularly with the my uncle's 7mm Magnum, Winchester Magnum, Remington Magnum. Anyway, there's a minimum size for the barrel, and there's a maximum size for the bullets. You have to be careful, because bad things happen. Anyway, now, note that, where was I? Sorry. Note that, in some forms, the way a tolerance is expressed looks like a measurement uncertainty. Stressing that again, tolerance and uncertainty are not the same. An uncertainty shows the margin of error in a measured value, while a tolerance shows the range of acceptable values. So once again, if I go 12 millimeters plus or minus 2 millimeters, is that a measurement, or is that a tolerance and uncertainty? I'd have to tell you. That could be rebar with tolerance and uncertainty. That could be measurement with a crappy ruler. I have to tell you. So be very careful about that, please. All right? Now, Serena is making a new front door for her house. In order to fit properly in the frame, the door width must have a nominal value of 30 inches and a tolerance of 1/8. If you have the old set of notes, I've changed the numbers. My apologies. Who the hell has a 24-inch front door anymore? Anyway, so it's the maximum and minimal allowable value. Ugh, try that again. Good afternoon, ladies and gentlemen. Question A. What are the maximum and minimum allowable values of the door width? Well, the maximum would be 30 plus 1/8. Sorry about that. So, in order to fit properly, the door must have a nominal value of 30 inches and a tolerance of 1/8. So, it's plus or minus 1/8, sorry. So how big is the door? Well, the maximum value, tolerance is half of 1/8. Mr. Sutton, you're getting old. Okay, so target is 30 inches, the tolerance of 1/8. Now, as I just said, going back here, tolerance here, so we go nominal value plus or minus half the tolerance. So the tolerance is 1/8. Now, I'm old, but I know that half of 1/8 is 1/16. So I can go this as 30 inches plus or minus 1/16 of an inch. All right? Yeah, I know, I hate this getting old. Anyway. So, 1/16, yes. So, that's how big the door is that she can make. Because if you've ever done carpet, you know there's a little bit. So, the maximum is 30 inches, 30 and 1/16 inches, and the minimum would be 29 and 50/16 of an inch. Now I'm really showing my age because I can do that 16th of an inch in my head. But let me show you quickly. Clear? 30 plus 1 divided by 16 is 30.01625. Oh, sorry. These new fancy dancy electronic calculators put it in decimals. Now, 30 minus 1 divided by 16 is 29.9375. And when you look at this, you realize the metric system's so much easier with centimeters and millimeters. You just move the decimals around. Anyway, so let me try this. Math. No, that's a crappy way to write it. I'm not going to show you that. Anyway, so that's the maximum minimum allowable values for the door, because a certain size to fit in the door frame. Now this is getting long, so I'm going to pause the recording here, and we'll go on and to the next question in the next video. Good luck.